Okay, Math 8 students, we are doing lesson 4.4, proportional and non-proportional situations. This is the last lesson in Module 4 and kind of pulls all of these concepts together. So what we're doing is we are looking at determining if a relationship is proportional or non-proportional, and we're looking at that in graphs, in equations, in tables, and using that to compare different situations in a real-world scenario. So we're just going to jump right in and look at graphs. So when we're looking at graphs, what we are doing to determine if a relationship is proportional is, first of all, we need to see if it's linear. Because if it is not linear, it will not be proportional. So we need to make sure it's making a straight line. So if we look at graph A here, we can notice that it is a straight line. So first of all, this is linear. It does make a straight line. And then what we're going to do is we're going to check and see if it goes through the origin. And it does go through the origin, which is our 0, 0. So it does cross the origin. So it is linear. It does cross the origin, so this is proportional. And remember, when it's crossing the origin, just to connect some concepts here, that means that when x is 0, y equals 0. So you would see that point as 0, 0, right? Just like we wrote up here. So let's compare this to graph B. So first thing we check is that it's linear. Does it make a straight line? Because if it's not linear, if it does not have a constant rate of change, it cannot be proportional. I'm actually going to write that up here. Must be linear, constant rate of change. To be proportional. If it is not linear, it cannot be proportional. It is automatically non-proportional. Okay, so back to B here. We're checking it's linear. It is a straight line, does have a constant rate of change. And then we are checking to see if it crosses our origin. And in this case, this line does not cross our origin. It has a y-intercept of 10. So when we look at the origin of 0, 0, it does not cross that. So instead, it has a value of when x is 0, y equals 10. So its b value, or its y-intercept value, is 10. Remember, that's our y-intercept. And that means that this is non-proportional. So let's go ahead and I want you guys to take a look at, we're going to call this graph C and graph D. And I want you to determine if these graphs are proportional or non-proportional. So there's graph C, there's graph D. So go ahead, pause for a second, work through those two, and then press play and check if you are correct. Okay. So checking graph C, first thing we're doing is checking to make sure it's linear. Yes, this is linear. It does have a straight line. It does have a constant rate of change. So then the next thing that we check is, does it go through the origin? And yes, it does. It does cross the origin at 0, 0. When x equals 0, y equals 0. So what this means is that its b value is 0, right? And that's just I'm just putting that down there because we're going to connect that concept a little bit later. So this graph is linear and proportional. And we're going to go over here and check graph D. So it is linear, it does have a straight line. And then we're going to check, does it cross the origin? No, it does not. Nope. So then we're going to look at where it does cross the y-axis, and that is at -2. So when x is 0, y is -2, which means b equals -2. So this is non-proportional. proportional. And this is kind of some bonus information, guys, connecting concepts, but all you really need to do on a graph is look, does it cross the origin? No. Doesn't cross the origin? Non-proportional. Does it cross the origin? Yes. Crosses the origin, and it's a straight line, proportional. All right, so that's graphs. We're going to go ahead and slide on down here to equations. And so what we have with equations is we've got two formats here. This very first one we've got is our slope form, where we have m for slope, versus our slope-intercept form, which has slope but also has that y-intercept. And that y-intercept is what tells us it is not proportional. So like I said, we're going to connect some concepts here. That b value represents, if you look at the graph right above it, where the line crosses the y-axis when it crosses somewhere besides 0. So in an equation, if you have y equals mx plus b and you have a b value, it is non-proportional. If you look at an equation and it does not have a b value, or it's plus 0, right? We're imagining this is plus 0, then it is proportional. So if there is nothing behind that slope, that rate of change, then it is proportional. Y equals mx is proportional. Y equals mx plus b is not. Okay, so we're going to look at these examples down here. And I'd like you to try and identify them on your own. So pause the video and see if you can identify these, and then press play and see if you identified them correctly. Go ahead and do that now. Okay, so hopefully you paused the video and worked through these. So what we're going to do is we're just going to see if these match up with y equals mx plus b. Okay? So this equation right here, we're looking at number 5, and this is slope form because it is y equals mx. There is no b value, so this is proportional, which means it would start at 0, 0. It crosses the origin. Let's look at number 6. This could be form y equals mx plus b. So since this has a b value and this b value is 2,000, this is non-proportional. Because b equals 2,000. In this case, whereas the previous one, b equaled 0, because there's nothing there. Now let's look at this number 7. So this is y equals, and they tricked us here. They did b plus mx. It is minus mx. I'm just keeping things kind of simple here. So it does have a b value. It does have an initial value. It doesn't start at the origin. Even though they flip-flop these, that's okay. They can do that. So this is non-proportional. Because b equals 450. And then we're going to look at this last one here, number 8. Now this one is tricky because there isn't a plus b here, but there is not a variable on this side of the equal sign. So this is actually saying this is b plus, oops, sorry, not b plus. This is b equals mx. So it doesn't have a y in there. It's flip-flopped those a little bit. So we would write this in y equals mx plus b form. What that would look like is y equals 12x, or d in this case, 12d, minus 36. And it would be minus because we moved it to the other side of the equal sign. So this is in y equals mx plus b form. It does have a b value, so this is also non-proportional. And b equals negative 36. So if you can pull a b value from it, it is non-proportional. If you cannot, if there is no b value, it is proportional. And just to jump back here, the difference between 5 and 8, even though they look similar, is that this in 5 is a variable, whereas this value right here in 8 is a constant. It's not a variable. So that represents our B. That one was tricky. So then we're going to go ahead and jump into tables. Now, tables, what we got to do first is, I'm going to put a little checklist over here. Make sure it's linear. And that's the same thing we've been doing, and that means that we have a constant rate of change. Oh, so we are going to check our constant of proportionality, which means we are going to compare our y over x values for each pair in a table. And if it's constant, it's linear. And if it's linear, it can be proportional. If it is not constant, it will not be proportional. So we're going to go ahead and look at this table here, number 9, and we're going to compare these pairs. Now remember, we're putting y over x, so make sure you're putting your appropriate value on top here. So that first one is 30 over 2, which simplifies to 15, so we want to see that all the rest of these pairs equal 15, and that's going to tell us if it's constant. Okay? So then we have 90 over 8, and 90 divided by 8 does not equal 15. 90 divided by 8, because I worked this out already, is 11.25. So the fact that these two are different means that this is not linear, so it cannot be proportional. So since these are different, this is non-proportional. And I didn't even need to check this last one because these first two weren't the same. So I'm going to go over here and check this next table. And I'm going to do the same thing. I'm going to put my y over x and compare. So I've got 1 over 5, and that simplifies to 1 over 5. So I'm looking, this is what I'm looking for all of these to reduce to. I've got 8 over 40, and 8 over 40 does reduce to 1 over 5. So far so good. So I'm going to check that last one of 13 over 65. And 13 over 65 does also reduce to 1 over 5. So this is proportional. And I know that because this rate of change is constant. And then I'm just going to double check that because it should also go through the origin, right? So I need to work backwards with my constant of proportionality here. So this is a minus, or this is a plus 1 every time. So plus 5, which means to work backwards, I want to see what y equals when x is 0. So if x is 0, y equals what? Well, I can work backwards to get x to 0. I minus 5. And based on my constant of proportionality here, when I minus 5, I'm going to minus 1, and that gets me to 0 also. So this is telling me that I do have a constant rate of change, and it does go through the origin. So I worked backwards, and that can be a little confusing, because if I minus 1 from here, you know, eventually what you want to get is when x is 0 is y 0. So that's what you were determining here. And we worked backwards using our constant of proportionality. So you'll see tables with, like number 9, you'll see tables with different rates of change, in which case it is non-proportional. You'll see them with the same rate of change, which means they can be proportional. So then you need to check if they have a x value of 0 and a y value, a corresponding y value of 0. And you can do that by working backwards using that constant of proportionality, using that rate of change. Sometimes we'll get lucky and we'll get a table here like, I'm going to call this number 11 because then it corresponds to our other ones. And you'll be able to look and determine if it's constant first. So we're going to go ahead and take our y over x, and notice that that is different for this table. Y is on bottom, x is on top, so I need to make sure I'm putting these in the right order. And I'm going to do, oh, you know what? Actually, I don't even need to do that. I'm just going to go over here. Let's keep it simple. And I'm going to look at what these are increasing by. Okay, so my y is increasing by 4 every time, right? Because 7 minus 3 is a positive 4, 11 minus 7 is a positive 4, 15 minus 11 is a positive 4, 19 minus 15 is a positive 4. So, okay, so far so good. So 18 minus 6 is a positive 2. That should also mean that this difference here is a positive 2, which it is. And 4 minus 2 is a positive 2, and 2 minus 0 is a positive 2. Okay, so we do have a constant of proportionality. In this case, our y over x, our change in y over change in x, is 4 over 2, which simplifies to 2 over 1, which simplifies to 2. So that's telling us it's linear. And then this value right here tells us that it's not proportional, because x is 0, y is 3. So since y is not 0, since y is a value besides 0, this is non-proportional. This is linear, non-proportional. So we've got 3 different scenarios here. We've got 9, which is not linear, and consequently not proportional. We've got 10 here, which is linear and proportional. And we've got 11 here, which is linear and non-proportional. So you've got 3 different things that your table can be showing you. All right, finally what we're looking at here is our real world scenario. And so what we're going to do is we want to be able to compare 2 situations using tables, equations, and graphs, and determine if one is proportional, one is non-proportional. So, and then compare what that means in the case of this scenario. All right, guys, I had to pause the video here for a second, so hopefully my volume is not too off from what it was before. Might repeat myself here just a second. So we are looking at comparing non-proportional and proportional relationships in real-world situations. So we've got a scenario here that's comparing 2 laser tag arenas. Let's go ahead and read that. A laser tag league has the choice of 2 arenas for a tournament. In both cases, X is the number of hours. That's one of our variables here. X is the number of hours, and Y is the total charge. Okay? Compare and contrast these 2 situations. So X equals hours. That means this is our input, or independent variable, and Y is our total charge, which means this is our output. Okay, so we can create the equation y equals mx plus b here, where x is hours and y is our total. And m, of course, then is going to be our cost per hour, and b is going to be any initial charge. INIT. So if there is an initial charge, that's going to go where B is. So I'm going to just color code these because that's what I've been doing. Okay, so let's go ahead and look at Arena A. So Arena A is an equation, and based on what we looked at with our equations, looks like we've got a slope form, and it doesn't look like we have any y-intercept or any initial value. This looks like y equals mx. So this is a proportional relationship, which means it's starting at 0, and our rate of change, or our unit rate, is 225. That's our cost per hour, so that's $225 per hour. So what we're going to do here is we want to figure out after, we'll plug in a few hours, maybe 1, 2, and 3 hours, and see what our cost is going to be. So if y is our total cost, x is our number of hours, let's plug in 1 hour and see what that costs. So for 1 hour, that means that x is going to equal 1. We've got y equals 225 times 1 to give us our total cost. So 225 times 1, y equals 225 for 1 hour. Let's plug in 2 hours. So y equals 225 per hour times 2 hours. And that's going to give us a total of 450, right? So y equals 450. So for 2 hours equals 450. And then let's go ahead and check for 3 hours. So we're going to plug that 3-hour value in. Y equals 225 times 3 hours. 225 per hour times 3 hours. So y equals 675. So for 3 hours, it's going to cost $675. Okay, so we've got 3 comparisons there. We've got 1 hour, 225, 2 hours, 450, and 3 hours, 675.
Winter Minor, your mom.
Got an announcement here.
Pick you up. Winter, meet your mom outside. Thank you.
So comparing that to Arena B, which is our graph, first thing you want to notice is that it is a non-proportional relationship. It starts at a value on the y-axis. So let's see what they are counting in here. Looks like this is 50, right? 100, 150, 200, 250, 300, 350, 400. Okay, so it looks like there is an initial fee, right? Or initial cost of $50. And so this represents B in our y equals mx plus b. So our equation here is going to be y equals something, we don't know what our cost per hour is, x plus 50. So no matter how many hours they play, it's going to cost at least $50, okay? For like a, I don't know, maybe an equipment fee or something. And then let's go ahead and compare what they've got, the same amount of time that we put in for Arena A. So let's look at 1 hour. So at 1 hour, this is going to cost $250. So 1 hour equals $250. Then 2 hours, we'll just go up here. Looks like $450. Okay, can we find out 3 hours? We could. We need to find our equation. We need to find what our m value is here, what our slope or our rate of change is if we're going to find out what 3 hours is. So we'll go ahead and take the time to do that. We have 2 points, right? So this is 2 and 450. So I'm going to find my change between these two, right? And that's going to give me my slope or my rate of change. So y, change over y over change in x is 450. I'm going to run out of room here. Should have given myself more room. Try that again. So my change in y over change in x is 450 minus 250 because I'm trying to find my rise, right? 450 minus 250. Which equals 200. Right, because this is a plus 200. And then my change in x is from 2 to 1, right? From 2 hours to 1 hour. So my run is 1 hour there. So even though it's 4 squares, each one of those squares only represents a quarter of an hour. So you need to make sure you're measuring those units correctly. So this is a rate of change of $200 per hour. So if we just compare that to our Arena A is 225 per hour, right? And Arena B is 200 per hour. But it has an initial fee of $50. So let's find out here. So it is more expensive for Arena B for 1 hour. It's the same for Arena A and Arena B at 2 hours. And so let's find out if it's cheaper for Arena B at 3 hours. So we're going to go y equals our rate of change here, which is $200 per hour, 200 times 3 hours plus the initial cost of $50. So y equals 600 plus 50. So y equals 650. And so that's the cost of 3 hours. 3 hours is $3.50. Okay, so I made a little bit of a mess here in my work, so I'm just going to kind of square off a little bit of some space here. Okay, so comparing and contrasting, I'm going to make an equation. I already have one for A. A is y equals 225x. B is y equals 200x plus 50, right? Because it's got that initial cost. So if we compare these at 1 hour, A is going to cost $225. B is going to cost $250. At 2 hours, A is going to cost $450, right? I've got that information here. And B is going to cost $450. Forgot my symbols and units here. And then at 3 hours, A is going to cost $675. And B is going to cost $650. So, what we can deduce here is that depending on how long the laser tag league wants to play will depend on which arena is a better option. If they want to play for 1 hour only, arena A is a better option. If they want to play for 2 hours, either arena is going to cost the same. But if they want to play for 3 or more hours, arena B is going to be a better choice because it costs less than arena A. And that trend will continue. So even though it has an initial cost, after 3 hours or more, it's going to be a better deal. Okay. So you want to be able to pull that information from real world situations. And I did take a little bit of a long version explaining that, but I wanted to give you multiple representations of these scenarios. So that is it for 4.4, the final lesson in Module 4. There'll be a review video and then probably a walkthrough of one of the review assignments coming, and then you can expect our Module 4 quiz coming sometime next week. All right, Math 8 students, if you have questions, bring them to class so we can go over them, and I will see you in class.